Hey guys, how's it going? Welcome to another episode of Ferris Makes Hardware. So last week we were still working on this kaze language that I've been talking about. Made a bit of progress on some macro-y things, which I basically haven't touched in a week. Since then, I think I can just look at the commits because I don't remember exactly what I did. Been kind of a crazy week for me, which is quite all right, but a bit hard to keep track of stuff. So let's actually just look at what I did. Um, yeah, I think it must have been this January 9th one, working on if syntax. Committed it, did a couple more things. Still not super happy with that, but I don't really want to work on that right now, so we'll revisit that at some other time. Let's see. Here's some to-dos. I added value range checks for literals, which is kind of nice. Just some more safety stuff. Marked a bunch of types with must use so that people using the API actually have to use a lot of the return values. And same with like the one other function that didn't end up covering just by marking the types. Started going through the Rust API guidelines and starting to sort of make some changes for that, at least some of the ones that I knew about. So the generators now take a writer by value instead of by reference, by mutable reference. And then I think I added some doc to-dos to mention that because I haven't documented those functions, but I want to actually mention that you can use a mutable reference in place of a writer. This API guideline mentions that a bit more. I refactored like all of the sim code, mostly just broke it down into a bunch of different modules. Reordered some mux arguments like I wanted to do. I decided to take this like module, which is not a typo, and promote all of its contents to like the main API. So you just say use kaze instead of kaze module. And then I removed some docs that went along with that. I hit some macro stuff. Just did some more reorganizing internally with no like external changes. Removed an incorrect comment. So not that much stuff, I guess, but a lot of little nice things that it's kind of nice to putz on when I don't have that much time during the last week, which I didn't. So let's see. I think I might actually want to start generating some Verilog today. I think that would be kind of fun. But we may not get there. And the reason why is because one of the things that I've been really thinking about lately is validation. And we might end up working on that today. So with this language, there's a couple things that I want to explicitly disallow. There's a couple things I have to explicitly disallow, but there's some things that I actually want to disallow as well. So in particular, if you have instantiations of modules that would cause module definitions to be circular, so essentially if I have module A and B, and A instantiates a B, and then B instantiates an A, that doesn't actually make any sense. So that's a recursive module definition. So that's something that we have to detect and error. And it's actually quite important that no matter what we do with the API, we either... so currently everything with the graph is actually verified at graph construction time, except for a couple cases. One of them being you can't generate it in code if you have any register that's undriven, which it's valid to have a graph where a register isn't driven yet. So that's one case where like right after you create a register, it's not necessarily driven. So because you might end up having to drive it with its own output, which is quite a valid circuit, but is something that we can't really have an API to construct that any other way. So we need to detect that later. So there's some validation work that has to be done while generating the code, or at least as a pre-pass before doing that. And so I'm thinking I either have to do a validation pass that both simulators end up doing, which is probably what I'll do. But there's a few other errors, for example, detecting combinational loops, making sure every instance's inputs are all driven. Just some things that I think will catch a lot of errors. So I think I actually want to work on that first and figure out kind of the story there before I actually start working on some Verilog generation. Because then I kind of know all the constraints for the Rust simulator, and so then we actually start on the Verilog stuff, which again I keep postponing because I want to make these kind of decisions. But it should be relatively straightforward to make it match the Rust simulator generator. By the way, hi to guys in the chat. Dark Second, Niner Delta, Desu used. Hey Finrog. So yeah, there's still a lot more things to do, but at the same time, this is tending in the right direction. And I still am just like itching to actually use this thing lately. But I'm kind of trying to be a little bit disciplined and just kind of work through actually making this a proper API first. Which I think is going fairly well. If I do like a cargo doc no deps open. I'm still missing like a good intro and maybe a quick start thing here at the top level, but a lot of this stuff is documented. A lot of it's also not. For example, I think register is not documented at all, which is okay. We'll get there. Module, I think, is actually all documented except the top level stuff. Oh no, there's a couple here. The thing to create a register and the function to do a mux as well. But everything else is documented, so there's a lot of stuff covered. Signal as well, I think, is missing top level docs, and these like module and signal are definitely missing top level docs because I haven't figured out how I want to do again like a basic documentation of the whole API in a quick start. So I'll figure that out. Yeah, we'll definitely get back to Xenowing. I know it's been a few weeks that I've been working on this, but at the same time, like you guys are seeing most of the time that I have to work on anything actually. Like last few weeks have been kind of heavy, but at the same time I've been sneaking little commits here and there on this project. So, but yeah, definitely this is meant to drive the Xenowing project. So I'm excited to get back to that, especially the rasterizer. And then I think if we do a vector unit, I might even design it from the ground up using kaze, which would be really cool. But yeah. Cool. I'm glad you think it's fun. I think it's fun too. I think it's a cool idea, and it's going fairly well. I think this little API design. Also, I don't remember if I mentioned this last time, but I did some nice stuff with literals, where when you create a literal, you can mostly just type the value and then the number of bits. Breaks down a couple cases because, like for example, I have to suffix this with U32 because the entire API doesn't support any signed operations right now, which is something I'm gonna have to change. But for the 0.1.0 version, I won't deal with that. And the way I handle that is this lit function actually just takes, instead of, it's generic. So instead of taking a, excuse me, I just had dinner. Instead of taking a value object directly, it takes an, what is it? Is it into value, or I don't remember what you call it. We can just look at module lit, for example. Yeah, into value. So something that can be coerced into that. In addition to that, you implement all these from traits for basically all the unsigned integer types. And then you can basically use any of those, which is kind of nice then. You don't even have to use into or anything because the lit will do the conversion internally, which I really like. But I haven't done the same for reg. And the reason is because right now I take an option for default value. And if you type none here, it doesn't have enough type information to infer which specialization of the generic register method that you actually wanted to use. So you'd have to add a type annotation here, which is different from your bit width too. So I don't really like that. So what I'm thinking about doing actually is to separate to change the register API. So if you want a default value, then what you do is you would type that on a separate line. So you say like reg.default value or something, and specify it that way. And then we can do the same trick that we do for lits to get the nice syntax. Because I actually think it's a common enough case that you don't want to have a default value for some of your registers, especially in like a large, especially in a data path. I think right now the internally that's actually handled by giving everything a default value anyway. But I might change that. In fact, I probably will change that. But yeah, I think that would be good. So I'll probably make that change. In fact, why don't we make that change first? I like making those little changes. So let's just do this. And I think the register API right now isn't documented, so We don't have to document it now either. Can do that later. Let's see. That's now in this graph API. Oh, another thing I wanted to do. This is kind of cosmetic, but I called this IL, which is this intermediate language or intermediate representation for the simulator generator. I'm gonna call that IR because I like IR better than IL. Tiny change, but that's just something that I wanted to do the last couple days and forgot until right now. So I'm just gonna do that. I think it's just that and that. I think that's all we need to do. And here goes my stream. Yep, that was it. Can I do get div cached? Yeah, because that's it. So it's just a rename and some changes. Perfect. I'd be surprised if I was still working on at least the 0.1.0 version by the end of the month, because I kind of want to get it like published as a 0.1.0 and then start integrating it into Xenowing right away, and then all the changes past that. For example, we're dealing with signed values and stuff. We'll deal with on a case by case basis as we work on Xenowing stuff. I think that's the way to move forward with this. So I'm probably gonna end up spending. Let's see. We have 2 more weekends in January. And this weekend I'm really busy, but then next weekend I'll probably do a big docs push or something. And in the meantime, I'll putz at this stuff in the weekdays. Oh, I totally forgot, by the way, to bring up the font size. Sorry about that. But yeah. And again, I don't think the Verilog generation is going to be very hard because I know how to do it. But what I've been thinking about, and another reason I've been deferring, is I'm not entirely sure how I want to do the testing for it. And it might be that I just have it untested in the initial version of the library. Because another thing that I haven't really clarified is what version of Verilog am I actually targeting? And I think I also want to defer that decision because the version I'm targeting is whatever, like practically speaking, right now it's whatever the Xilinx compiler wants to accept. And I think that's actually quite reasonable for a first version. But I might want to hammer down on that later. So we'll see if I want to make that more formal or not. I don't yet. I know that for sure. Let's see. Yeah, the register change. That's what I wanted to do. So that's actually in this graph API here. And it's just called a graph because it's a module graph. And that would be in register. So it's actually a mix of places because if you go into module, that's actually where you create registers. So there's a function reg. And here we have this initial value. I'm just going to remove this. And then I need to, in signal, there's a register variant of this. Let's just do enum signal data. And this has an initial value, which is a value right now. And I think what I need to change that to is a ref cell of option of value. That's like the data model change. And then this also actually kind of coincides with propagating the optionality of this initial value to the backends, which I think is a good idea because I actually want, I've been saying that several times, that in the data path it can make sense often to have a register without default values. So I actually think this API also leads us to that internal representation, which I think is a good sign. So we'll stick with that. And then initial value is going to be, yeah, ref cell new none. That's pretty good. So that covers this part of the API, and then we need a way, before I update the documentation and everything, I need a way to actually set the register's initial value, so that will be on the register itself. So again, we have drive next, but we also have default value. And we can make this generic again. What did I call it in the other time I did this in lit? What did I call this? Oops. Crap, I lost it. It's at the top here, though. Yeah, v into value. I think that's exactly what I want to do again. Great. And also I can do this required bit stuff later, but I think I'll do all this as to-dos right now. And then document it later, because writing docs is really boring. So yeah, so we want to do panic if this register already has a default value. If this value, panic if value, I'll do value range check. Because again, like the lits, we want to be able to ensure that we can actually fit this value in the number of bits that the register represents. So value we also need here now. This is one of the reasons I reorganized all this, is so that we have a lot smaller files now. Because especially like Signal, it's still quite large because we have a lot of documentation, especially. That's easily half the code, which I think is good. Again, the internal model for this API is so small, which is one of the reasons I'm actually okay with making this thing in the first place. But yeah, we do this, and we know this is okay. And yeah, we don't care about any of that. And so then we say register is not reg, it's initial value. Like this, and then that'll be value. Hey, cheat detector. Yeah, of course, that's going to be value.into. Where do I do that in lit? I do it somewhere in here. I'll do the same thing with this. Then it should work. So then we still have the same working API, and now when I update the documentation, I'll basically do the same thing, except the simulator output now needs to handle this being conditional, which is what we also need to change. I might want to extend the register test to explicitly test for that. And I don't really know how I'm gonna do that. I guess I can reset the module, the generated module, and then check that its value hasn't changed, which I think would be a reasonable enough test for the simulator. I think I'll do that. Anyway, let's start with updating the docs and everything. Or I guess not, it actually makes us update the simulator first, probably because it's just building the crate. That's fine. So then, are there that many places actually that do this? Sim 120, let's go into there. Wouldn't have thought so, but yeah, I guess because it's referred to a lot here. So initial value here. See, what is it doing here? Oh, this is actually fine. Because all we want to do is borrow this. And then if it's not none, then we want to actually set it here. Otherwise, we don't want to set it to anything. So this actually will be really easy, I think. So if let's initial value is initial value, then we do this. Otherwise, we don't. Easy. Yeah, this is dot borrow too. I think we also want to do that. Hey, now this isn't by reference anymore. Easy. Okay, oh, now it doesn't like this value's moved. 116. Okay, then we'll do this. Actually, I still think we do that. Then it works out, but now, of course, that's a reference again. So we actually had that right the first time. Yeah, I think we're okay there. Easy. Yeah, I expect some of these doc tests to fail. That's great because these would be registers. Yeah, I guess some of these will just have none as initial values too, which is fine. So signal RS41. Oops. Which is this one, and that just has no value, so that's fine. So we can do .reg, find that maybe. I think we're done there. What's the next one? Value.rs14. Yeah, and so the point of this document is document where value might be used. And so we actually do want to do, like, let's see is this, and then we'll do c.default value. And then the value is 5u32 in this case is what we need to do there. So I think that fixes the docs cases. And then we have the simulator test case that we need to update to. So that'll be easy. That's just in the sim test thing. And then in build. Probably doesn't show us because it's build script. So 131. That's again none. So we're fine there. In fact, all these are none. Uh, 365. I think actually these tests want to have default values that are 0. For like all of them. So we might want to change that. Actually, I'm not going to run the whole suite again. We'll do kaze sim cargo test. Yeah, so that passes. But again, I want to look at some of these tests because I think, for example, reg test module, I think you have to reset and propagate. It expects them to be 0 because it checks these initial values. So I think it's actually more correct to have all of these tests actually have those explicitly specified, which is fine because we'll just do r dot default value. We can do 0u32. We could do false if we wanted to. Doesn't really matter. Let's see, m.reg is also this. And we'll just do the same for all these. Oops. Which is not quite the same because in this case we want R1, R2, R3 here. This should end up the same because I think we use default for initialization of these structs now, which is not quite what I want to do actually, but we'll get there. So I also want to extend this original reg test module here to have a couple different registers. So we'll change this, and that should change the input and output names. So that's going to fail a bunch, which is great. Now we go back to, I think modules, no, lib, where it's actually tested. And then this I becomes, all these m.o's become o1s, and these i's become i1s. So what I want to do is add another register without a default value. And we'll just test that explicitly. Here we'll do I2 and O2 for those, and then we won't have default value. And then in the test, did that. I like that language. So m.i2 is 0x fade babe. M.prop. We can do that propagates it to the register, and then we can do positive clock. So now we clocked it in, and then we can propagate it to the output again. So then here we can do assert EQ, and the left is m.o2, and the right is 0x fade babe. Okay, and then with reset. So then we can do m.reset and m.prop, and then we should be able to assert the same thing as there after that. I think that's what we want to test, and that works, so I'll take it. And the last thing I want to do is go in here and do cargo format again. Oop, I don't have that actually, so we'll do rust up component, add rust format, and now we'll wait. Oh, that was it. Okay, great. Okay, kaze sim, cargo format. Now we should be good. Some test code. Looking good. Yeah, I'm quite happy with this. Hey, Love Like Semtex. Hey, Dura 2. Great. There's so many of these little changes too that like I've thought about a lot. Pretty much every time I'm in the shower this last month especially, I just think about a lot of these API decisions. And so a lot of these I've already arrived at in my head, but I haven't had time to sit down and actually write them. So good to get them out now. That's some good stuff. I still think though we have... Yeah, I guess the remaining things for parity with the Python impl is syntactic sugar and Verilog gen. But again, one of the reasons why module instantiation is still not marked as done is because I wanted to figure out that validation story. I have a couple to-dos that came in with that. So for example, if we look at the simulator generator code, I think it's in compiler now. Just look for the to-dos. Yeah, so we're like undriven inputs. Haven't figured out if I want to report them here or when they were connected, but I think I do want to report them as part of a validation pass. And same with registers that are undriven. I think this is okay. And yeah, I think that's what I was thinking too, is in order to determine whether you have undriven registers Actually, undriven registers probably isn't that bad, but we'll get to that. But to determine that you don't have any combinational loops, you also have to kind of flatten the graph, or at least be able to traverse it through the module hierarchy like we do for the simulator generator, even though in Verilog we would just be probably generating a single module. Or I could do the flattening for both, actually. Which I've also been thinking about, and maybe that actually makes the most sense, because then we always have the same validation pass by virtue of the fact that we're flattening the graph. Maybe that is the way I want to do it. Maybe that makes things a bit simpler, and we get a lot more code share between the generated, or the simulator generator, and the Verilog generator. But one of the reasons why I keep going back and forth on that is because if you describe a module that instantiates another module, and then you tell that to generate Verilog, Verilog has a concept of module instantiation as well. And it would seem wise to use that, to leverage that. It seems that would be the least surprising thing to do. At the same time, as a user of the API, if you only wanted to generate like a top-level module, you also have to generate all the dependencies. And you wouldn't know that until you tried to build the Verilog code. So flattening everything would solve that. And again, I'm probably overthinking it because this is just the first version of this library anyway, so I might as well just pick one and stick to it. And the more I think about it, the more I'm actually leaning towards always flattening, which would be kind of nice. And then we wouldn't do an initial validation pass, or I might still want to do that if it makes sense. But yeah. You know what? I'm going to make a split-second decision, just decide to do that, so I have a direction to move in. And then we'll go with that. Yeah, I think I'm okay with that. However, the compiler thing here is going to be a little bit different, I think. Because to generate a simulator and to generate Verilog code, there's a lot more lowering that happens in the simulator generator than what's going to happen in the Verilog one. So, yeah, I think I still want different compilers, but this first pass where we gather all the registers and see what's kind of reachable through the graph, that can probably be shared with both generators. The only difference is that this compiler needs to gather all the reachable registers, whereas, or it needs to gather all the reachable registers and then also assign them names, whereas I don't think the Verilog generator would need to assign them. Well, yeah, it would. If it also does the flattening, actually, that will also do that. So, how do I want to do this? I could also stick with this instance stack thing, which I don't actually love because it's kind of wasteful on all these nodes. Whereas like a hierarchy of contexts is more what I want, or would achieve the same goal but be less wasteful with memory. It might also be more direct because then we can just have references to these everywhere, as long as the lifetimes work out, which I think they would. I know a lot of the things that I'm saying may not make sense because it's like internal details of this very specific compiler, but just thinking out loud like I always do anyway. And it is true, actually, that, again, if we flatten this and we're generating Verilog code, I still will generate different, like a node for the next value and then use this current value for the register itself. So actually, this would be valid for both passes if we flatten the graph in both cases. So then I think what I want to do is I actually want to separate this gather registers pass so that it doesn't live on this compiler object, but on some kind of other object, or it might just be a function itself. Maybe that's what I want to do. Do I want to do that first, or do I want to try and refactor this instance stack thing? I think I want to try and refactor this instance stack thing. So, because that probably makes traversal easier for both passes later, which is something I would like. Just going to run the test suite again just to be sure before I start. Always a good idea, I guess. Of course, everything still passes. Of course it does. That means I don't have enough tests. But that's not what the road we're gonna go down now. So the idea behind this idea is that we sort of flatten the graph, but I actually don't like actually flatten the graph. So the first implementation I did for the simulator generator that did this sort of flattening for adding instantiation would do an initial pass where the first thing it does is it makes a new context and then actually flattens the graph. So it will traverse everything and actually flatten. But it ended up being a lot more code altogether than the alternative, which is instead of actually flattening, give us the ability to sort of traverse through like up and down the module hierarchy as we go through the reachable nodes. And so I ended up sticking with the latter, but it does end up with some duplicated code to go in and out of these different contexts, which right now what I end up doing is I have these maps. For example, all of the reachable registers can be identified in like a flattened graph or like a global graph by the stack of instances that you use to like drill down into it from the top level, and then the signal itself, which is like just one way to kind of express this. Another way might be to, instead of having instance stack here, have like a reference to like a flattened module or like a flattened module context. I'm not really sure what to call that. Module context is probably what I'll go with. And that would sort of be the same thing, but then this would just be a reference, whereas now this is actually an object. It's this stack object that is parameterized on an instance. And the stack object is literally something I made for this little compiler, where it's like this sort of, it's this really functional programming reference counted kind of stack. So this is kind of a heavy object to be cloning around everywhere. Not terribly heavy, but heavy enough. Whereas that would just be a reference. And well, I guess that is true that most of the time when you're copying these, you're only copying a reference to the top node, so it's probably not that bad. But equality checks, I think, have to traverse the whole thing, and then you have like a linear time equality check, which scales with how deep your module hierarchy is, whereas this could easily be just a pointer. So probably makes sense to do that. And then there's a couple times where, like, if we want to look at the registers and go from trace signals into these register inputs, we kind of have to start with this stack and then kind of drill up if we hit like an input to the module where that to an instance of that module. Yeah, it's kind of confusing. But we definitely need more than just the original signal as a reference to identify the register, because once the graph is flattened, you need to know that, yes, this is that particular register, but it's that register within the context of this flattened module. And that's, again, why I think I'm going to do like module context for that. Alternatively, I could also just refactor this to have the two separate passes like I had before, where you do a flattening pass first, and then you do on the new graph, you do all the other traversal. But I think I'll go with what I'm talking about, where I'll have this context thing. So that will allow us to get rid of stack, because let's see, how do we want to model this? Well, first of all, we want to have, for example, struct module context. And this is definitely going to have lifetimes because it's going to have references in it. And let's see. I think this is going to have a map, which I don't know what to call yet. And this map is going to be from an instance. a particular instance to another module context. And that way we can, whenever we hit an instance while we're traversing the graph in this context, we'll know that we need to have another module context there. That's going to become our new context, and then we'll start drilling into that, which we would do if we hit an output. So that, I think that makes a lot of sense. And then we also need like a parent context, which every module context except the very top level one has this. So the parent is going to be an option of reference. And or module context A. Look at this really unique, well thought out name that's literally just the types of the hash map. I think that's fine. Could also call them children if I wanted to do this. Yeah, we can do that. Okay, and then instead of having an instance stack here, what we're going to end up with is a context, which I think makes a lot of sense. So if you have this signal in this context, then that is an explicit or an explicit register. And if you have this signal in this context, it's a specific expression. And they can be different. The same signal can be mapped to different expressions depending on the context in which it's used. That's perfectly natural. So that's what we want to describe. So compiler now also is going to have an arena, which we need to pull in. So I think, where did I do that? Typed arena. Now about this arena, I think because I want to separate this pass that builds this module context graph thing. I want to separate that into a different pass first, and eventually I think I want that on a different object than this compiler, but we'll deal with that later. So for now, we'll just do context arena. It's going to be an arena of module context. And the arena itself, we might want to force it to have this lifetime, which I think we can do. I think actually technically we want to have a different lifetime here. And then the module context would actually have the lifetime of the arena. And then we want to express that arena doesn't live as long as, or that the modules, or like these instances, have a lifetime that is at least as long as the context itself. That's what we want to do, I think. It looks like, though, we might not be able to specify the lifetime for given arena, which again I think is probably okay because it's going to be on this object anyway, so we might just get that lifetime stuff for free. That's probably okay. We'll run with it and see if the compiler yells at us. It's always a good option with Rust. So here we'll do context arena. We'll do arena new. And yeah, so the other thing we were doing is here we were passing this instance stack around. And instead of doing that now, we're going to pass in a module context. So instead of instance stack on all these different places, I'm just going to do this search replace thing. Or actually, we'll just start with this. We'll start with context. And maybe I want to reverse the order of these. I kind of feel like the context should be first before the signal because this is like the bigger thing. This is the signal within this context. Yeah, I think that is what I want. So here we'll do context is the module context. And so another thing we actually need too is sort of a root context, which is fine. We'll do that. Root context, and that's going to be a module context of that lifetime. Which I think we can do like this. And then that, and then root context needs to be context arena.alloc module contexts. And here we have parents is none, and children is hashmap new. And we might get an issue because this was moved already here, but I think if that's the case, we'll move this out here, and then I think it all works out. We'll see. Okay, yeah. So when we reach an input and we have this module context, what we're gonna end up doing is instead of popping off the instance stack like we do here, we try to look at the parent. And so we say, yeah, if let some parent context is context.parent, then we would do all this. We need an instance here. Oh, right, because if we have a parent, then that means this instance, this module context represents the context of an instance in particular. And so we need to know when we're going to the parent context, we need to know the instance that represents, that the previous context represented, because here we're kind of going up the instance stack. So I don't just want to have like an option of instance here. Would they always come in pairs? I think that's the case, actually. We can call this instance and parent. Again, really clever here. Because you only have a parent if you represent an instance. So we kind of capture that optionality like this, which is nice because if that's the case, you actually want both. So what we can do then is in here, we say context.instance and parent, and we can do ref instance, ref parent, context. Let's call that parent in here. Also, do I want a pointer here? I actually think I want a reference here. And same with this one. I also want a reference. And also here I want pointers actually. Because we're hashing them, which works just fine. Yeah, this is okay. And also here we need these double parens like we had before. And for instance and parent, do I need, because this instance is a pointer, which also doesn't need to be because we're not hashing it. So this also we can do a reference. And then we actually don't want to have ref here because we're not taking ownership. We're just getting these references here. And we also don't need to do that. It's not a pointer, so we don't need to dereference that like that. So then this becomes parent. That's okay. Also, these inputs that aren't driven, I'm thinking I'm going to do as a separate validation pass. And just in the internal model of store, a list of all the inputs for an instance, which you actually kind of already have, but I think I mean a list of all the instances for a given module. So we can just go over all of those in a pass before this. And then this one never has to worry about if the driven inputs contains this name, which is kind of nice. So I think I'll do that. Anyway, there's a lot of these instance stack things here. We'll get to this one in a second because that gets more complicated, but all of these are going to be the same context. And an instance output. So it's going to be a little different because here, yeah, we get the output. So what is the case here? The case here is that we are in like an outer module, and we're traversing the signals, and we come to an instance output, which means there's an instance of a module inside our module, and it has an output. So we've traversed, and we're going to enter that output basically. So yeah, I get the instance and the instantiated module and those outputs, and the one for the same name that this output matches. And then this output is now a signal in the context of that inner module. So instead of pushing a new instance on this instance stack, what we actually want to do is look up on our context to see what the child one is that matches that instance. And if there isn't one, we're going to insert one, which is going to be a new module context in that case. So I'm actually going to save some code here because I know we're going to do this. We'll do new, and we can do, we'll just take the instance and parent like this. And this will return a module context. And then we do module context in here, and we do instance and parent. And then children is hash map new. And this makes this a little smaller because this will be new none. And then down here, we're going to instantiate the other one. And then the next pass will never need to do that conditional instantiation. It will just always do a lookup in this map here. So this gather regs pass is kind of pulling double duty here because it's also kind of checking for errors, which again I think I'll do that in a separate pass. But then it's also gathering these registers, which it kind of needs to do for whatever the first pass that goes over this is going to do, because you need to know what signals can propagate to what other signals, and one of like the sinks for signals is the outputs of all the modules, but it's also the inputs of all the registers. So you have to enumerate all of the available sinks and then trace all of those as well. So that's kind of what we're doing by gathering the registers, is gathering all the sinks that we don't know about yet. Because the outputs are explicitly listed, but the registers aren't necessarily reachable, so we might be able to optimize them out. So that's kind of what we're doing here. Anyway, this instance stacked up push again is not what we want. We want context.children.entry. And for that, we're going to give it Yeah, we already have this instance. So I think we can do instance. Is it or insert? I always forget this. Rust hash map. That's this entry API, which is a nice feature, but I never remember the name of these. Or insert it is. Not insert or, it's or insert. I think there's actually an or insert with too. Yeah, which where we give a function, and that's kind of nice. And here we can do module context new and then sum, right? Because we have the the current context and this instance. So we would do context instance. Didn't like that. Probably forgot a paren somewhere. Just that one, I think. Yeah, I think that's all right. Okay, and then this context thing here. Actually, we're not done here because we have this instance stack handling in reg. And this again was just cloning these for these keys, which is not what we want to do anymore. We actually want to take the context as a const pointer. And this is just context. Yeah, that's not bad at all. And here we'll do context. And I'm also well aware that this may end up just blowing up in our faces later if I didn't get these lifetimes right or something, but I think we'll be okay. Which is something I say all the time. Okay. Yeah, we have this instance stack tail stuff still everywhere. Which we'll deal with that one because it's basically the same as the other case. And this one's different. Instead of context push here, we're going to do context dot children, and we give it the instance. And that should just work. In that case, that's great. And then the other case we have is here, where we get the input, which we're doing the same thing where we have to like jump out of the stack to the parent. So we're going to do the same if let sum that we had up here. So I guess that's what I kind of don't like about this pattern, is that there's a couple different places that know about that sort of going into and out of modules. But at the same time, it's a relatively straightforward thing to do. That's probably okay. So instance and parent now is what we want here. And that'll be that kind of parent. That might be it, actually. Instead of instance stack, we do this. Like that. And then again, we don't need to dereference that. We might have ended up with less code here. And it's definitely going to be more efficient, which is nice. And now there's no mod stack because did I delete the file as well? Probably did. Sim. Yeah. Okay, did not like this. But that's okay. Oh, I do. Yeah, the top level stuff has this instance stack, which is not what we want. We actually want the c dot root context. Is that what I called it? Probably. Why am I not borrowing? Did I describe that wrong? Probably. Yeah, stack doesn't exist anymore. Expected module context, but got this. And reference, yeah, I think I did this wrong. I think it needs to be that. What's wrong here? Oh, take a reference. It's also not right to do new here. I just realized. Because this should be self.context arena.alloc. And then, oh yeah, this sum should be outside of that. Or, no. Sum is in the wrong place. Because we still want to do module instance there, or module context. I called it instance, which is wrong. Oh no, I forgot a paren or something. Oh no, I do still want new here, don't I? One parameter is specified, and that's because I need to make this a tuple. Expected instance found module context. Wait a minute. I think this is still correct. Context instance, that's what I give the parent and the context new sum parent and the instance. Seems correct to me. Makes it easier to read. Did I just do this in the wrong order? Context and then instance? No, it's instance and then context. Okay. Then that's literally what it's telling me. Okay, now it can't figure out the lifetime. That's not what I wanted. Okay, but here, look at this. It even says just to add that to the context. Was that enough? For autoref, which is this one? Can I do that? Does that not work there? Probably not. I'm not sure why this doesn't work, actually. You know what we can also do for this is try and write it the other way, which without this lambda, which probably makes it clearer. So then we can do if not context.children.contains key instance. Then we say context.children.insert. And that will be instance and then this crap. Okay, does that work for this? That? How was I doing this in other places? I guess I probably constructed the key first. So I think if I do instance as pointer const, whatever, and then we end up with a reference to that, I think that solves it. Why not? Oh yeah, because we need the type. Right, so let's do that let key pattern here too. I'm fine with that. And that's actually this. Key there too. It needs a reference, so that's fine. But then do the lifetimes work out? No, they still don't. I'm not entirely sure why, actually. Is that because we haven't been able to describe that the objects in the arena live as long as everything else? Not totally sure there. That's frustrating. Grenadine, thanks for the follow. Appreciate it. Just gonna run it through the compiler and see if it tells me anything more. It probably says exactly that though. Yeah, I think introducing new lifetime is probably what I actually wanted to describe anyway, but I don't know how to attach that lifetime to this context arena. That's what I'm kind of worried about here. Ooh, also, there's another place where I use instance stack. It looks like. I'm going to fix that really quick. That's probably, yeah, I think it did because of this. But now we just change that to context, I think. That's actually what we want to do here too. Did make this public here? Probably. Yeah, that's that error at least. But then we're still left with this one, which is here. Also, I'm going to fix this other issue. It's just easier for me to look at this stuff when everything else is out of the way. The 317 in here. Is that it? What? Expected pointer found an instance. No expected reference found this kind of reference. But is that not what we wanted? Oh yeah, because I didn't use key here. That would do it. Can I do that? I don't think so. I think it wants the reference, which is fine. But yeah, still with the lifetime issue. Also, to try and split this out, let's do this. Yeah, still same thing. So the idea is we have this arena, which is on self. And when we alloc in that arena, we should get a reference that has the same lifetime as self here. Yet for some reason, we put that in this list. That reference doesn't live long enough. I'm not entirely sure why that's the case. Hey, Wistertobe. So, I'm surprised it didn't complain about this one as well. So in this case, the root context had this A, and we know this context has that same lifetime. And here we're probably going to have to annotate that as well. Maybe not, but I think... And maybe not actually, because we never create new ones there. That's probably fine. And I think also here, in this module context, we insert... All these children have the same lifetime. The same one as this, which I think still makes sense. Lifetime of context children. That should be the lifetime of the context. I think that's okay. Yeah, how would we set this explicit, or how would we explicitly set this anonymous lifetime? How do we do that? Maybe let's try and do something like child is like that. Maybe that works. Maybe that does it? No, because you can't do that. Yeah, but the self-referential is that's okay for these, right? Because the module context isn't meant to own these objects, right? And it's okay if the lifetime is like self-referential like that, because that all that says is that these things that we store, like these references, live at least as long as this, right? Or do we need, or is that not the correct way to do that? Because we could do like B, for example, and make these instances B's and the module contexts A's, which I think is still correct. I mean, this is actually more close to what I want, which is where I have like that we say that. Can never remember. And then you need to, of course, pass all these, but I don't think that that's the right solution necessarily. Yeah, because we define lifetimes here, so it's actually that we would do. I mean, this is more explicit about the fact that these graph instances do have a different lifetime. Did I get this backwards? I totally got this backwards, actually, for A and B here. Because I want A to be these other graph instances in the module context. I actually want to have lifetime B, right? But again, I don't think that this is the actual issue here. This would be a B and a B here, right? No, I had to get wrong again. It's so confusing. Yeah, A graph instances and then B module contexts. Something like that. Oh, hey, I figured it out. I got it, you guys. You ready for this? Boy, aren't you guys going to feel as dumb as me. This needs to return a reference. And then, yeah, this module context is... Wait, no. That's actually... This is correct because we want an instance here. Okay, I didn't solve it. Never mind. Because we want this to live... Yeah, that's not what I want to do. So... But it is still correct, though, that the module context, I at least want them to have the same, like, how do I say it? I do want to express that the children live as long as this. And I think that's okay. I don't think that that's the core issue. Because that just says to me that all of this stuff can be from the same allocator, for example, which is actually not true for the graph instances. Those actually should be technically a separate lifetime that lives... That's at least as long as the lifetime of the module contexts. So I am trying to save a bit of typing by not being explicit about that. Maybe that's the issue here. But my gut feeling is that that's not the problem. I could try to actually describe that, though. So if a compiler then had two lifetimes, right? One for sort of the input types and the one for these. So this context arena has, well, we can start with the module context. Have two of these. So the graph that we're taking as input is all going to be A's, and the things that we're producing are all going to be B's. And so again, we can just say the same with the inputs, then the outputs are the B's. And I think we also need to describe that B has at least the lifetime of A, which is what we do there. Of course, we actually, we have to give both lifetimes to these module context instances here. And so it's going to be B, like that. So the compiler needs both because it has references to, the compiler's also going to have this because it's going to create its own objects that live at least as long as the objects that it also references. Yeah, it would be nice to get rid of these because they wouldn't necessarily need to have the same type, I guess. Not sure about that one. Let's try removing it just to see. But that is what I want to describe. So in this case, the module contexts are going to be, we need A and B. The module context reference itself has the lifetime B, right? And then all these module contexts again, A and B, B, and the signal is always A's. I think we're okay there. And then here we need, for the input compiler, we need these. Yeah, root context is B. It is, because it's going to come out of this arena, essentially. The arena is where that B lifetime's coming from, ultimately. So here, these are B's. Oh yeah, but again, we need to specify both A and B, which are both lifetimes there. And then we might need to be explicit that a module context is a B. Yeah, that's not it either. So it has correctly inferred the lifetime must be valid for the lifetime B, right? But I think that's only because we've the parent had lifetime B, and so then this one ends up having that lifetime as well. Maybe I should search this error, cannot infer appropriate lifetime for autoref. I could do arena. So we could the way we describe that then, we'd have a module context and then we'd have a graph lifetime and a compiler lifetime, right? So all these graph things need to have this graph lifetime. And the module context needs to live as long as the compiler. That's kind of what I'm trying to say here. So I think what we want to do now is do a big search replace here. And for all the A's. So what this should correctly infer, the lifetime must be valid for lifetime compiler, right? Which I thought was going to be this. Because we do take compiler.contextarena.alloc, right? What am I getting wrong here? Hey, run cargo. I can do that again. That's this. It's basically the same. We can't infer the appropriate lifetime for autoref. And I'm not entirely sure where autoref comes from. I guess it comes from alloc here. And looking at, so this is the typed arena crate. And typed arena has an alloc function. Alloc takes a reference to self and will return a reference to its child, which I would assume had that same lifetime, or at least a new lifetime that inherits from the other one. So what I don't understand here, right? It says first the lifetime cannot outlive the anonymous lifetime number 1 defined on the body. Not 100% sure about that one. Probably because unmute self. Wait a minute. Maybe that's it. Maybe and self needs to be compiler. Whoa. Now I got a move. This move we know how to deal with, actually. Cannot move out of context arena because it's borrowed. Because I borrowed it for this. Can't return a value referencing local variable context arena. Data owned by the current function. Returning this value requires that context arena is borrowed for compiler. I thought that this compiler would sort of inherit that lifetime. Maybe it doesn't because context arena moves in this case. Does that end up being the only issue now, though? So what is it doing at 131 there? That's probably the other function. Oh, this is also saying this, but let's say. Oh, that's the top level stuff. Yeah, I could move the arena out of the struct, which is actually kind of, I think, what I wanted to do anyway. Ultimately, so I might as well just deal with that. I'm hoping we end up being able to like move it out and then actually erase all these lifetimes, which is probably what we'll be able to do. Wouldn't mind doing that, I guess. Okay, but then compiler is the wrong name for this, because then it would actually be arena. So we'll start with that. Like that. And it's going to tell me the same stuff. But then what we can do, then arena would get this lifetime. That seems right. Then at least we're clear about that, which is nice. So context arena is not going to be created here now. And then root context will create on that same thing. We'll call this context arena as well. And then maybe everything else just works out. And then we don't need to take it as a reference because we already get that reference by virtue of having the compiler. That's where that reference ends up living, which is fine. And then I guess this would be here is probably where that's complaining. So if we do let context arena is arena new, and then here we have arena. Then it doesn't have that type yet. I'm gonna do that. Right, and now we can't borrow C as mutable, which is kind of interesting. Oh, because we take the root context there. That's annoying. I mean, I get why, because the root context is there. But the other thing we can do is we can move out the root context, right? That's the other thing that we can do for that, which I'm actually quite okay with. We don't really need the root context to be there, especially if we're going to access it publicly like that anyway. So we can do that. So we don't have root context there, and then this code out here will do this. Oops. Module context is private. We'll just deal with that for now. Oops. And then c.root context becomes root context. Why? But we clone that. Yeah, that's true. We don't want to read on self now because that doesn't live there anymore. That's true. That's very true. So self is now in mute self without arena. No, we don't want this context to be mutable. Why would it think it's mutable? Oh, because we insert children. That is actually true then, right? Okay. That might just work out. Or actually, we might want to use internal internal mutability on that. Yeah, I think that is actually what we want to do. We want to do a ref cell there. Not very pretty, but I think that would actually work. Because we don't, I guess actually, I know another way to solve this, which aligns better with my goals. Thanks for the help, guys, by the way. Another way to solve this is, instead of making this mutable, whenever we create a module context, since we know the instance, we know that's going to have a certain amount of instances inside of it. And so we could actually create those contexts up front, and then they can just stay immutable. And then we never need to do an insert at this level. So in the pass before this, it would actually create those, or it would just do it here. But in order for that to work, we need the instance. We need a module to contain a list of its instances already. Which, again, we could do in a previous pass. So I think maybe that's how we end up solving this. I think what I'll do is I'll do ref cell now and then change that. So we'll do yep, and then double colon there. And so we'll do ref cell here. Okay, and now it's going to yell at me for not borrowing, which is quite okay. Let's do this long form. That's okay. Whoops. Wrong place. There. And in fact, if we want to go back to this syntax here, then it's borrow mute, which I think is okay. Maybe not, actually, because gather regs might borrow this again, and we only want to borrow it mute for that insertion. So we want to make sure that this ref doesn't outlive this call here. And maybe it doesn't if we do it this way. I'm going to try this. We'll see. And then we'll do borrow here. That doesn't like this. Temporary value dropped while borrowed. Yeah, then we'll see if this got away with it anyway. I'm more than happy to take a longer syntax as long as it works. And this is a little more explicit about when we're borrowing it mutably anyway, so that's quite okay. All right, it builds now. Thanks for the help, guys. I think you're right about that, Freezy. So this is quite okay. Now I wonder actually if we still need to specify these lifetimes. Probably. Again, we can get away with typing a bit less if we just say that these are the same lifetime, which is not technically what I want, because this is technically more permissive, even though from the perspective of these functions, it doesn't really care. So I'm just going to try doing that because we don't really care. And I think we still have the arena one. Again, this is semantically different. Oh, it actually caught that as an error. That's fun. Was that out here? Yeah, because now it knows that this context arena actually doesn't live as long as this outer lifetime for the graph. Okay. Then we have to be explicit in this case. Now we know. I mean, this is correct because these are actually unrelated lifetimes. Technically, actually, they're not because we need to make sure that arena lives as long as graph. And I guess the compiler probably infers that in cases like this. So I actually didn't get that bad just on this. What'd you hit with learning Rust? Not sure what you mean. The main thing we want to run here now is the sim tests, which I expect will work, but we'll see. Yeah, and they work, which means this also generated correct code. And again, I think this is going to be faster because it makes these types a lot simpler. So all these things that used to be a map from essentially a linked list and this to whatever we needed now is just 2 pointers. So it's a fat pointer basically. So that should actually be nicer. And I think this way of expressing these contexts like this is kind of nice too. Yeah, sometimes you have to fight the lifetime system, but I don't mind that this looks the way it does actually. Because at least it's compile time checked, which is pretty sick. And then the only thing here is that now we have this context arena, which is maybe not something I would have liked to have escaped outside of this module, but I'm not terribly worried about it. Yeah, I'm going to commit to this for now at least anyway, and then we can adjust it later if we want to, if we have to. But this, yeah. Vector instance stack into module context. Even do ref counted linked lists. We can try that. I'll commit this and not push it. Yeah, as long as the compiler can prove that root context doesn't outlive the arena, which should be fine. Let's just try it. Oh no, that's what it was. It was that we borrow C here and then we have to pass in root context. That's what it is. So we have an immutable borrow to C via getting root context out here, and then we also borrow C as mutable. That was the issue there. That's why I extracted that eventually. I'm just gonna add a bit more notes here. No, you do still want to pass it here because this gather regs is recursive. So sometimes we call it with the root context like we do here. But there are times where we have to, for example, compile signal where we take the context of that register as well. So that's the issue there. I'm more than happy you're bringing this up because I'm happy to double check. So no worries there. Appreciate it. Yeah. Cool. We'll do that. So yeah, didn't quite get to the Verilog gen. We still got a bit more things to do, but I think this was a good change. Again, just semantically, it makes more sense to have these as sort of fat pointer pairs rather than linked list pointer pairs. Cheaper and a bit more. Like, other than all these lifetimes here, I think the code itself is easier to understand, which is kind of the important thing. Oh, I should have run cargo format on that, which I can just amend the commit. Yeah. I hate when it does ugly stuff like this. But we'll just accept it. And here's the advantage of no one else ever touching your project. You can just force push to master. And I'll just run the tests one more time. I know they work, but I'll just be sure. Yeah, I can look at making aliases. I'll do that next time I look at this, I think. Actually, why don't I do that now? That's a good point. I mean, these are different. It's the context key, really, which that's actually quite okay because I use that as key, so we can do that. Although this is the opposite as well. Yeah, well, I'll worry about that later. All right. Anyway, thanks guys for hanging out, and thanks for the help. I'll see you next time.